how to evaluate these three types of the double integrals. So type 1 is, can we observe here, x1 x2 are boundaries, type 2 is y1 y2 are boundaries, and type 3 is x1 x2 as well as y1 y2 are boundaries. So here x1 x2 are constants, y1 y2 are in terms of x, and y1 y2 are constants, x1 x2 are in functions of y. So these are all constants, x1 x2 and y1 y2 are constants. So how to find these type of double integrals? I can give you graphical representation also. So here the formula is, first we can, x1 is equal to x2, we can fix this one, integral y1 of x to y2 of x, integrate with respect to y, then loss. This is the formula to find double integral in type 1. Type 2, integral y1 y2 are boundaries, that means constants, integral x1 of y2 x2 of y, f of x comma y dx here, then dy, because y is the boundary, that's why last integrate with respect to y. And then here we can consider either x's are boundary or y's are boundary, because all are constants. So we can follow two formulas, integral x1 to x2, you can fix first x here, and between this integral y1 to y2 f of x comma y, which limit source belongs to y, that's why we consider with respect to y first, then last. Or you can take same analysis with y boundaries, y1 to y2, so you can consider here y dy, and integral x1 to x2 f of x comma y dx, which is belongs to x limits. These are the mathematical formulas. I can show you graphical representation for this each and every. For suppose I want to take two-dimensional xy plane, I can consider two curves, like this is one curve, this is another curve, and which is represented by y1 of x, which is represented by y2 of x. So let us take boundaries are x boundaries, so that's why we can consider this is one boundary, this is another boundary. Let us consider this one. This is x is equal to x1, this is x is equal to x2. These are the boundaries. So let me consider, this is the region of integration, this represented as region of integration. So x's are boundaries, x is equal to x1 and x is equal to x2, these are the boundaries. And y limits are, here y is y1 is equal to y1 of x, or y2 is equal to y2 of x, and this is y1 is equal to y1 of x. So this is the graphical representation of first one. So here we consider the boundaries. See, similarly second case number 2, again this is also, we can consider the xy plane. This is xy plane, but I consider two curves here, like this is one curve, this is another curve, which is represented by x2 of y, which is represented by x1 of y. So I can take here y's are boundaries. For example, this is one boundary, this is another boundary. Here y is equal to some y1, here y is equal to some y2. The region of integration should take vertically, this is the region of integration. The boundaries are y1 is equal to y is equal to y1, y is equal to y2. So here we should consider constants. And what about x limits? Here x1 is equal to x1 of y, and x2 is equal to x2 of y. So these are the y limits. This is the reason of integration in case number 2. And coming to last case, case number 3 or type number 3, these are the graphical representations. So I should consider all our boundaries. For example, this is one line, this is another boundary line, this is another line, boundary line, this is also another boundary line. So which represents x is equal to some x1, which represents x is equal to some x2, which represents y is equal to y1, y is equal to y2. So in this case we can take boundary either x's, or for suppose we are going to take y boundaries, we should follow second formula. We should take x as boundaries, we should follow first formula, either first case or second case, sub cases. So for suppose we consider the first case, the reason of integration is this one towards this one. So this is represented is horizontally, we represent this one, case number 1 or type number. Next, for suppose we want to take this case, this is the reason of integration. So this is the graphical representation in double integral with 3 types. Thank you.